In this one, we're going to be doing Vertex Animated Textures. It's one of the ones I'm most excited about. I think this one is going to be really, really cool. And I'll kind of show you what we should end up with at the end of this video to kind of give you a sense of where we're going. I already do have a scene here that has all these, walking characters in it. And we see this all the time in games now, especially these like kind of big mob games where you have lots and lots of characters. But what's happening here is really special, and particularly for publishing a game on web, you need to be really mindful about optimization. If you look at what's in the scene here, you might be surprised to see that there's no skeletons, right? There's no skeletons, there's no animation player, there's no rigging at all. And what we have is actually just a single multi-mesh. This is just a single multi-mesh instance. And we've got, I believe, 10,000 instances here. Yeah, so we've got 100 by 100 grid. So we've got 10,000 people. They're all animated on these walk cycles. And in fact, the walk cycles, if you look carefully, you'll notice they're offset from each other. And everyone's going at a kind of different rate. And we can do other things too, like we could change the speed of each one of the walk cycles. We can change lots of things. But this is all possible due to Vertex Animated Textures. And what that is, I'll show you briefly. If we look at the mesh is just a fairly low poly skeleton, or a low poly base mesh. And actually that mesh comes from Open Game Art. Let's see if we can find the base mesh. It's this one here. So we are going to go through the whole process of downloading this and using it. But the magic happens because of these textures here. We have this position texture and this normal texture, and they actually encode all of the positions of all of the vertices for the mesh for the entire walk cycle. It's really, really cool technology. We can take a brief look at the shader as well. So we pull up in the shader. This is actually even very simple itself. It's we'll walk through exactly how this works, but basically we grab the information from that position and that normal texture. We do a little bit of math, and then we just offset the vertex data based on those texture values. So I'm going to show you exactly how to do this, and we are going to start right at the top. So what I've got here, I did do what I'll call a test model, and that was where this test scene came from. But we're going to build this up properly. And I want to do an asset folder for this. And we're going to call this is going to be the male model. So we're going to put in male here as a new folder. And very first step, you're going to see this link is going to be in the attribution. This is CC by attribution, so be mindful of that. But we're going to go ahead and download human.zip, and we're going to really just start from the top, and you'll see how fast this comes together. So I'm going to bring in my zip file, 96 kilobytes, so really not too much going on, and we'll open up this blend file. Now, I've opened this blend file a number of times in the past. I really don't like how it's laid out. So what I like to do is open up a brand new Blender file, just an empty one, and we're going to copy in the mesh. We don't need the animation that's here. We don't really need any of that stuff. So what we're going to do is Control-C to copy. And now that we've pasted it in, it does have a bunch of other stuff we don't want. I'm going to first zero out the position. Nope, that's not what I'm going to do first. I'm going to clear the parent and keep the transform. And then I'm going to remove the armature as well as the edge split. So the armature, we're going to delete that. Now we can do this. And screencast keys, I believe, is on, so we should be good. At this point, I like to tab in and just bring the feet up to the x-axis here as close as we can, just to kind of get that zeroed out. And I want to make sure everything is applied. So we're going to apply all transforms. And now we have our base model in Blender, and it's pretty clean. I usually also like to delete all of the vertex groups, because those groups would have been associated with the old skeleton. So let's just call this male, and I'm going to rename this a little bit. I am slightly neurotic about having all the naming match, and we definitely don't need a material on this, so we can remove those. All right, so this is pretty clean. The next thing we're going to do is use something called a meta rig, and we're just going to use a basic, I believe it's basic human rig. Now what you need for this, if you go to preferences, You need Rigify, I believe, is what gives you this. Yeah, so these are Rigify rigs. Let's take a look at the docs quickly. I think they tell you add armature, and then this is what you get with your predefined rigs. So we're going to be using the basic human rig. So go ahead and install Rigify, and once that's installed, you should be able to just hit check, and then the way we're going to do this is we're going to hit Control A. We're going to add a rig, armature, and then basic human rig. So the first thing you notice is that it's not quite in line. We need to get this in line with our rig, and what we'll do is we're going to do viewport display on this part. Is going to be in front. So that gets our bones to show up in front. So we need to scale this guy down, and what I'm really looking for is that these shoulder joints are where they should be, okay? So before we go ahead, we're going to apply all transforms on this, then we're going to tab into edit mode, and we're going to turn on X symmetry. So anything we do to this side, we do to the other side. First thing, we're going to select these three and try to get this, rotated. Sometimes it's a little bit, wonky how that works, but rotate it till it's flat, and then get it roughly in place, right? You got to think about where these pivot points are going. We're going to be moving these bones. Really what you want to be looking at is the joints. So where's the joint sit for the elbow? Where's the joint sit for the wrist, right? And then the hand bone should come out to the fingertips. You can also shift this. There's no problem with kind of moving this stuff around. I wouldn't raise this up a whole lot. You want to make sure these joints are in the right place. Now what we can do is we can set the roll to 90 on these three, okay? Roll is 90, roll is 90, roll is 90. We don't need the breastbones here, so we can shift click and delete those bones. The next thing we're going to want to do is probably focus on the hips and the knees. The hips are in a pretty good spot, actually. There's nothing wrong with those, but you can move them if you need. Move the knee bone into place. We're going to grab the entire foot and slide it across. And then next we're going to go into side view, and the whole rig needs to come back a little bit if you notice this. So we're going to grab all of them and slide them back just a touch. Okay? And then get these kind of into place. Hip is still good. Knee looks okay. Ankle can come up a little. We're going to grab the entire toe bone and put it maybe here so that bend is in the right place, and then the heel bone should sit right on the heel. All right, so that's all pretty good. We come to top view. We got some stuff to fix up here. This shoulder bone definitely could come in a little, and this guy should be like this. There should be a little bend in the arm here. I learned this a long time ago. I forget why, but having a slight, concaved bend there is good. And that should be okay. We go to side view once more. This is the one that's probably in the wrong place the most. We're going to bring this down. This needs to be more in line with the chin, and then these two can be equalized. And I find that this method works well on most rigs, and it's just a general piece of advice that I've found, that the base meta rig, these two neck bones are basically too high. Now, that's all good. Our rig is there. Everything seems good. We're going to want to make sure scale is applied. All that stuff is good. Should be okay. Now, what we can do next is we're going to generate the rig. And you do that by going here. So under bones, scroll to the bottom, we can generate. And now we get this rig. Now, here's the part I occasionally forget, but I think we shift-click the base. And actually, before we go ahead, I'm going to power save. So once again, if you haven't installed power save, that's a really good add-on. I believe it's under extensions now. Power save. No, it's not. So power save. You'll have to download the power save add-on, but Blender power save add-on. Yeah, I guess it's here under blenderaddons.org. Actually, I haven't seen this site before, so I'm not sure. It's interesting. But definitely get power save. It's worth it, particularly with rigging. I find it to be very, very helpful. If you screw up a step, it's easy to go back, right? Rather than trying to undo in the editor. So we're going to click the mesh, shift click this armature, and then shift click that armature. And I think we do parent, so Control P, and then with automatic weights. And if we did all that right, we can flip to pose mode, click this guy, and we see this. Okay. So that's all pretty good. So now we have a rig that works. The next thing we're going to be doing is basically going to Mixamo, grabbing an animation, and then using the Rococo plugin to get it to work. All right, so this next step, before we get to bringing that into the editor, is anything that uses inverse IK. So inverse IK is basically we can move the hands, and you'll notice it also reorients all the other joints. We don't actually want that, so what we're going to do is for the hand, we're going to drag the IK, FK all the way over to FK. So everything is going to be forward kinematics, and that's going to help with the retargeting process. And once you do that, you'll notice that these handles don't move anymore, but the green ones should. The green ones are the forward kinematic handles. Okay? So that should be okay. Next step, I'm going to suggest you go to Rococo, log in. You will need to create an ID. You can download the Blender plugin. So Rococo, Blender plugin. Okay. So once you create an account, you should be able to download it, no problem. You install it like a normal Blender add-on. And once you get it, it'll show up here. And it will ask you to log in. It brings you to a website, and then you'll get back here. So grab Rococo. We're also going to go to Mixamo, and we're going to grab an animation. I'm going to show you the good animation settings for that. So if we do, I'm going to have to log in again. We're going to want a walking animation. You can use whatever animation you want, but let's go with walking. Let's just do this one. I think is what I grabbed before. So this one should be basically identical to what I had done. We're going to want to check in place. So make sure you do that. And then we'll do download. And we don't want the skin. And FBX, 30 frames per second, none is fine. So we'll download all that. So that is going to download. And then we get this walking FBX. So I'm going to grab this and bring it over to my folder here. If I hit F5, I should see my power save, but this didn't go in the right place actually. Let's see. Oh, sorry. Well, let's go out one level. Let's bring the FBX here. Okay, so here's where our Blender file is and our power save, and we get that. Okay, so next step, we're going to bring in this FBX for walking. And the only setting you need is automatic bone orientations. All right, so we bring that guy in, and you should be able to scrub along the timeline or hit play, and you should see that walk cycle. Now, sometimes this is not quite the right size, and let's see if we can make this a little bit more easy to see. Yeah, it's not perfect, and you'll notice the bones are kind of in weird places. So if we go to rest position, you can see it a little better. You kind of want this to be scaled up just a touch, just so those shoulders are in the right place. It'll help match everything better. So let's scale that up a little and apply all transforms. And you know what? I'm actually going to check first. It has a rotation on 90, so we need to be careful here, and the scale is 0.1. So definitely want to be a bit careful here. I'm actually curious if it matters. I think somehow I moved the keyframes just now. There we go. Yeah, I somehow grabbed all those keyframes and moved them. I'm actually going to keep the rig exactly as it is, and I think you don't need the scale to match. Don't quote me on that, but I'm pretty sure the scale doesn't need to match. So the reason I don't want to change it is because sometimes scaling rigs and applying transforms really messes up the animation. So let's just say that you're going to keep it as is. Now, both of these I want to be in the rest position, all right? I want them to be in the rest position. I'll go to Rococo, and what we want to go to is the retargeting tab. This is going to be the important one. The source, you're going to click on the armature up here, and then the target is going to be this Rigify rig. Now, once you do that, and we can simplify this a touch, we're going to remove the meta rig. So we just have a little bit less visually to contend with. And you know what? We should bring this viewport in front as well for this Rococo rig. Okay. Now, if we go ahead and build the bone list, it gets it very, very close. And in fact, you can scroll through this list and see what you get. I'll just do a slow scroll so you can pause. Okay. The only thing you need to remove here is this first spine is not correct. There shouldn't be any deformation on the spine. And what we can do is we can go ahead and retarget at this point. Okay, I think auto scale, this feature is what makes it so you don't have to rescale the Mixamo animation, which is the correct approach to take. So let's go ahead and hide that guy, and we should see now we have a walk cycle. So that's pretty sweet. We got an animated walk cycle on our base mesh. All right, now this is where things get kind of wild. We can take this mesh this animation that we've retargeted, and now we're going to use a script. I have a slight modification to the VAT plugin. That one is right here. So this is a Blender plugin by this person called Flement. All of the attribution is within the plugin itself. It uses a GNU public license, so I made a small modification here and I called it version 1.0.1 or 0.2. This was published very recently, so should be really good compatibility. Now, the way we're going to do this, we're going to close this guy. We don't need that anymore. We have this here. I'm going to go to the modeling tab, actually, and just to give myself another tab, I'm going to do a horizontal split. We're going to switch this to text editor. And in the download files for this module, you're going to see some files. And I want you to open the script here. So this is basically the exact same script, except I bumped it up, made a couple modifications, and you should be able to hit play here. And when you do hit play, you're going to get this VAT plugin. And the only thing you need to do for whatever animation you choose, you need to know what the end frame is. So we're going to go from frame 1 to frame 32. So we click on our mesh. So we go from 1 to 32. We're going to use offset mode. We're going to flip Y, and we don't need to wrap. And all we're going to do is process and in meshes. Okay. So then we get this new export mesh, and you'll notice it doesn't quite exactly line up. That's because we need to scrub back to the beginning. So this plugin is so cool. So what it does, we're going to hide that. We're going to hide the rig. What we're left with now is just this export mesh. And we should have gotten a couple of images as well. So we'll try to talk through what these are. We get positions, which is this. And we also get normals, which is this guy. Now what we have, if we look at our statistics for a second, if we go viewport statistics, you'll see this thing has 410 vertices. These textures are 410 pixels wide, and they are 32 pixels high. So it has, every column is a vertex, is a unique vertex, and along the vertical direction is all of the frames of the animation. And we should see all of these transitioning smoothly. And the reason we want to see smooth motion is because our animation was baked with very smooth, fluid, animated motion, and it looped perfectly. So we shouldn't see any, the gradients should also be quite smooth. Same with the positions, we see smooth gradients. So what is it we're actually looking at? What we're looking at is it's basically the difference between the first keyframe pose of this mesh, like what position are all the vertices in the first keyframe, and what's the difference between that and the next frame, and encoded as RGB. All right, there's a couple settings. We are going to use the exact settings that are listed here. So on the VAT plugin website, the documentation is pretty good. Tells you what kind of modifiers you can use, and they tell you what kind of export you should do as well. But I'm going to give you some more specific settings on the Godot side. All right, so we have this model, and what we can do now is we're going to hit F3 export GLTF. This is our pretty standard pipeline now. We're going to go to our project. We're going to go to Assets, Models, Mail, and we're just going to call this mail.gltf. Format is bin plus textures, include visible, and this should be fine. The one more thing I'm going to mention here is about the UVs. You will notice you have a second UV map, okay? And this Vertex Anim UV is pretty important. It's going to come in as UV2 in Godot. And what it does is every single vertex gets mapped to, this is should be exactly, there's some math that needs to be involved. So let me see if I can figure it out. There's, what did I say, 410 of these. But then it's going to be shifted to the left slightly. So 122, it's probably divided by 820. I think that's right. And so the reason we divide it by 820 is because we want each one of these vertices is uniquely mapped, basically, is what I'm trying to say, right? This is uniquely mapped. If we look at the X component of UV2, this uniquely identifies the vertex, and it clearly puts this vertex on like whatever this frame is. So remember, a column is a vertex, and then the y-axis is the frame you're on. So what we're going to do in code is we're going to grab this, and we're going to move it up by frame to do a sampling. So we're effectively going to sample our animation data at, say, this exact, for this vertex, we're going to sample it, you know, right here, whatever keyframe this is. That's the gist of how it works. Okay. So next step, we're going to have some stuff come in Blender. We'll check that out. Looks decent. So we're going to do set mesh save paths, and we can just set current folder. It should work fine. Okay. The next thing we need to do is we need to export these images. So we'll do positions first. We'll do image, save a copy, should be fine. Go to our Godot project folder, assets, models, mail, and then we'll do, this is the important part, we're going to do OpenEXR, we're going to do float full, and this has to be non-color. So I played with these settings. These are the ones that work the best. So we'll save that. EXR is really important because you can encode negative values with EXR. And then we'll look at normals. I think something went a little bit weird here. Let's see. This happens sometimes. I don't know why our normals disappeared. It might be because of how it's rendering right now. I'm not sure. Let's see. They were fine a minute ago. I did notice this the other day as well. This happened. Let's go ahead and try to save it and see what happens. So we'll save this as normals, EXR, float full, and non-color. No, so that image lost its value. Not sure why. So the quick way to deal with this is we're just going to delete this mesh, bring back our mesh here, and then we just run the tool again. So process anim meshes, and then we go to, we should have normals.01, and then we can save this image. So I have encountered that a couple times. Not really sure why it happens. So OpenEXR, RGB, float full, and then non-color. Okay, that looks a little better. Now, of course, what we need to do, we're going to throw in just a quick little testing mesh here. Mesh instance 3D, and we're going to test it on this mesh. All right, so here's our guy. He might not quite be the right scale for this world, but we can fix that with a scale option pretty easily. All right, so say he was with a scale of 2. That's totally fine. Now the next part is we need to get a shader on here. So this shader is going to be shared with you as well. And what I'm going to do is in the VAT test shader, I'm going to make a new shader under here, and we're just going to call this VAT. Yeah, that's fine. So, and this is not a script. This is, I want to make a shader. And we're going to move this to, yeah, just keep it here. So vat.shader, we're going to copy this one. And when you download the project, you'll see VAT. You'll get all my test stuff here as well, but the test files are really not organized super well. So this will be a little bit nicer. All right, so what do we do next? We're going to open up this mesh. We're going to clear this. We don't need a shadow. Shadow mesh might help. We'll keep that. This material here, we're going to make a new shader material, 3D, right? So there's that shader material. We will save it. We'll save it under assets, models, mail, and then let's say mail dot material. And we're going to quick load our VAT shader. Now it goes black and it does this weird thing, but don't worry too much. We're going to set some stuff in here. So total frames is 32. So it goes from 1 to 31. Actually, I think that's, how many frames is that? 31? Frame count is 31. Yeah, sorry, this is 31. And 30 FPS is what you want to shoot for, so we'll go with those. And then all you do is you bring in positions and you bring in normals. However, you're going to notice this is quite messed up. So how do we fix this? Under the import tab, when you double click on positions, you're going to change the preset to 2D and then re-import it. And then we need to do the same thing for the normals. And this is going to basically, if you notice, our shading is way nicer now. So we don't have any issue there. The color is black because we haven't set a color. We're going to set that through the instance custom, the RGB on that. And we'll get into instance customs later. But the really cool thing is that this is a very, very general VAT shader, this one here. So however you want to use VAT in your project, you can use this pretty easily, right? There's some interesting like swizzling things that need to happen. But overall, this is super flexible. And where it comes from is right on the texture add-on page. They include a sample shader for GLSL. You need to modify it a little bit to work with Godot, but I've done that for you here. If you want to use other textures like normal maps and things like that, you can. You use them in the normal way where you create a sampler. And then you can, instead of using UV2, you're going to use UV1. Just to talk about the actual code here for a second, it's pretty simple. We grab the time variable, which right now is set from the time instance, and also we can do an offset. So we can do an offset for that to give, you know, the characters different walk cycles. We grab the time and then we do a mod function. So we're going to mod that with every frame. So if I say there's 30 frames in a second and I take the time as at 1 second, then this is going to be 1 second times 30 frames a second. So we get a value of 30 frames here. And then we mod that with the total number of frames. So what's the remainder when we divide by 31 frames? In this case, we would get 30. If we set this to 40, the mod, like, let's see if we can do this. If we did like 30 mod 31, we get 30. But if I did 35 mod 31, you get 4, right? I think. Yeah, what's the remainder when you divide that into 31? You get 4. So that's why we do mod 31. That gives us basically the remainder after looking at how many frames there are, and then we divide by the total frames. So we get like 30 over 31 or 4 over 31. It gives us a nice normalized value to see what frame we're at. So that's our frame value. And remember what we said about Y. We start down here in the bottom. Let's look at the positions. We start down here in the bottom, and we notice that this guy's black. And it should be black because relative to frame number 1, there are no changes in the vertex position. So this guy, there's no change. And then for each subsequent motion we go up, we go minus in the Y direction by that frame count. And remember, UVs go from 0 to 1. So UVs go to 0 to 1. Our frame is now normalized 0 to 1. We travel up this way, and that allows us to sample our position and normal texture at the correct location on this map using UV2. It's really, really a cool system. Hats off to whoever figured all this stuff out in the first place. It's a great way to conceptualize baking and animation right into Blender. And I will say, there's about 1 million things you could do with VATs. For instance, if you decided to do a procedural animation in Blender, there's nothing preventing you from baking that out and then using it in Godot. So I'm like super excited to see what kind of stuff can be done with this. Yeah, I just wanted to see the normals were working properly, but it is really cool. It's honestly quite exciting. So we get the delta in position. The normal, we got to do this little thing where we multiply by 2, -1, so we get a -1 to 1 range. Very typical. We have to do this swizzling. I'm not going to explain why that is, but left hand, right hand stuff. We grab this instance value, which is you're going to see comes from a multi-mesh data that we can set. And then literally all we do is offset the vertex and then bump the normal position. So it's really as simple as that. I'm also using that instance custom to color the mesh. So that's why this guy's black right now. But that's it. That's the, let's call this the male test. That's the male model walking around. And we can have thousands of these. There is really no issue with doing many of these. But of course, in OpenGL, if you just create a bunch of mesh instances, we get a bunch of draw calls. So that's not very efficient. Okay, so that all went pretty well. We did that in about half an hour. I love this stuff. I think it's cool to see how powerful. Like if you look at what we're doing, we used Rigify, we used Rococo, we're using this VAT plugin with a minor tweak, and all of a sudden we get access to like super powerful game dev stuff that AAA companies are trying to do this kind of thing. This level of optimization. There's 10,000 units here, and it doesn't even stutter, doesn't even blink, right? 5 draw calls, super impressive, and most of those comes from shadows. If we turn off shadows, then you'll see we get a single draw call. So honestly, it's very impressive, and we'll see how this looks in the game. The way I plan on implementing this is I'm going to have a multi-mesh or a series of multi-mesh instance 3Ds that we kind of have these pools of people. So maybe 100 at a time, or maybe even a bit more than 100. We'll see. It might be 500. And as people go to the houses and people start populating the houses, we can spawn them into the map and kind of have them move around based on the A-star grid 2D. I think it's going to be a cool system. We'll see what kind of like random motion we can get. It would be really cool to see people like walking around the yard and such. But yeah, we will cover that in the next one. For now, we just have a nice little test mesh here for Vertex Animated Shaders with shadows and lighting and everything. So that's very cool.